Good morning, subscribers. Today I'm going to do another video about STP and a common question that you would see on the Cisco exam. Here is a diagram with default port priorities, MAC addresses, and the speed of the links between the two switches. Now, the question asks, you need to determine how traffic will flow between the two switches in the topology shown above. This is the topology. No VLANs are configured on the switches. So, which port will be blocked? Select the best answer. Now, when you look at a topology, the first thing you have to do is determine what is the root bridge. So, the first thing you do is look at the priorities. This priority has a default priority of 32,768. This switch has a default priority of 32,768. So what is the rule? When the priorities are tied, you then go to the MAC addresses. You look at the MAC addresses from left to right, and you determine the switch with the lowest MAC address. These are all zeros. These are all zeros. This is 0C6 5, and this is 0C60. So this would be the MAC address that is lower than this, because 0 here is lower than 5 here. So with that being said, this is the lowest MAC address, so this is the root bridge. Now, the rule is all ports on a root bridge are forwarding ports. They're designated forwarding ports. So if they're forwarding ports, then they're not blocked. So no ports will be blocked. Hold on, which port will be blocked? So if they're forwarding ports, they will not be blocked. The gigabit port on switch B will be blocked. So the gigabit port on switch B will not be blocked because they're forwarding ports, right? The gigabit port on switch A will be blocked. So if this is a gig and this is 100 megabits per second, then a gig is faster than 100 megabits per second. So that means it will not be blocked. It will be forwarding because it has to forward to get to the root bridge, right? This port right here is the gig port. It will be in forwarding mode. Now, the gigabit port on switch A will be blocked. No, it will not. The fast Ethernet port on switch A will be blocked. Yes, it will, because a fast Ethernet port, which is 100 megabits per second, whenever you hear 100 megabits per second, you automatically have to think fast Ethernet. Fast Ethernet, 100 megabits per second. 100 megabits per second, fast Ethernet. Fast Ethernet, 100 megabits per second. I said it 3 times so you can remember. Now, will be blocked. Yes, it will be blocked because, and this goes back to the STP port path course, but each port has a path associated with it, and 100 megabits per second is 19. Okay, the fast Ethernet port on switch B will be blocked. And again, the fast Ethernet port on switch B will not be blocked because it is a designated forwarding port because the port is on the root bridge. Okay, so the answer would be D. The fast Ethernet port on switch A will be blocked. I'm going to show the answer. And this is the correct answer. And the explanation. This is the explanation, which basically entails what I just said. The fast Ethernet port on switch A will be blocked. When 2 redundant links exist between 2 switches, expansion protocol will prevent a switching loop by transitioning one of the ports to the blocking state. The blocking state in STP is equivalent to the discarding state in rapid span tree protocol. Neither STP nor RSTP supports load balancing over redundant links. And that's a little bit more information. Here we have information about the bridge priority. From 0 to 65,535, the bridge priority. And as you see in this span tree protocol, this has priority of 32,768. Okay, that's today's lesson. Just a little bit more about span tree protocol, which you'll see on an exam. And I would like to thank you guys for viewing. Thank you.